Hi. This demonstration is laboratory compaction of fine-grained soil, ASTM D698 and D1557. We perform laboratory compaction in order to define compaction curves of dry unit weight versus moisture content in soil. To perform laboratory compaction, we need a few things. First of all, we need some soil. This is some soil in a bucket, about 5 pounds of soil, passing the number 4 sieve. And this soil has been mixed with water and allowed to hydrate overnight for about 16 hours. So I have 5 pounds of soil here. We need a compaction hammer. Now, I mentioned there are two standards, 698 and 1557. 698 is also known as the standard Proctor compaction test. This is the standard Proctor hammer. It's the smaller of the two. It has a weight, there's a steel weight in here of 5.5 pounds. What you're going to do is you're going to compact the soil by dropping this weight from a height of 12 inches, a total of 75 times, 3 layers, 25 drops per layer. So there's not as much effort going into compaction using the smaller hammer, the standard Proctor hammer, compared to the larger hammer, the modified Proctor. Now here's the modified Proctor hammer. Instead of a 5.5 pound weight, it has a 10 pound weight in here. Instead of dropping 12 inches, you're going to drop it 18 inches. And instead of dropping the weight on the soil 75 times, you're going to drop it a total of 125 times. So what you'll be doing is you're going to place the soil in what we call a compaction mold. And here's the compaction mold here. It consists of a base. It consists of the mold itself, which sits here, attached to the base using some wing nuts. And you have a collar, which sits on top of the mold. Once you compact the soil in the mold, you take off the collar, you trim off the excess using a trimming bar. This is a bar, a steel bar with a beveled edge here for trimming that. You'll take this mold full of soil and you're going to extrude that soil. You're going to obtain the weight of the compacted material. You're going to need to obtain moisture content, so you need some moisture content cups. In order to get, for this particular target water content, calculate the dry unit weight and the moisture content of the soil. So let's take a closer look and let's actually perform a compaction test. We'll use the standard Proctor hammer. Okay, now I'm ready to do my compaction. It's a good idea to do this on the floor rather than on the table because it's going to put quite a bit of force into the compaction mold in the base. So, good idea to do it on the floor. As I mentioned, we have the compaction mold. Now there are two mold sizes that are specified in the ASTM standards. There's a larger mold which has a 6-inch diameter, but this smaller mold is a more common mold size. It has a diameter of 4 inches and a height of approximately 4.58 inches. When you calculate the volume is exactly 1/30th of a cubic foot, and that facilitates calculation of the dry unit weight later. So the first thing we do is we take it, we make sure it's securely put together with the wing nuts. Now when you compact this soil, it's going to be in the mold pretty tight. And in order to be able to extrude it, in order to make extrusion a lot easier, it's a good idea to use some kind of a spray lubricant. So we can just take that spray lubricant and spray on the inside of the mold. There we go. Now, here's my soil. It's been mixed with water to achieve some target moisture content, allowed to hydrate overnight, 16 hours. So this is the standard Proctor test, the smaller of the two hammers. So what we do is we compact this soil in 3 layers or lifts, and each layer is going to have 25 blows from this hammer, so that when it's all said and done, 3 layers, 3 times 25 equals 75 blows total. So each layer should occupy, after it's compacted, each layer should occupy about 1/3 of the mold. So here's what we do. We just take some soil, And I'm going to put it in here. So that when it's loose, it'll probably fill about maybe a half of the mold. And I know that when I compact it, it's going to compact down so that it's only filling about a third of the mold. So the idea is this: I take my hammer and I'm going to put it in the mold, and I'm going to do this 25 times. And I'm going to move the hammer around the soil and compact it. So I'm going to bring you a little bit closer so you can get a better look. Okay, here's a closer look. I have my mold full of loose soil. I have my standard Proctor hammer. Now I'm going to put it in here, and I'm going to compact it 25 times. I'm going to drop the hammer 25 times for this first lift. 1, 2, 3, 4, 5, 6, 7, 8, 21, 22, 23, 24, 25. I've compacted that first layer, that first lift, 25 times. So if you look in here, what you will see is a relatively smooth surface of that first layer. Well, we're going to put another layer on top of that, but we want to have good bonding, good contact between those two layers. So what we need to do is take some kind of a sharp object. A large screwdriver is a pretty good tool for this object. I'm going to take this screwdriver and I'm going to roughen up that surface. This is called scarifying the surface. When I scarify the surface and I put the next layer of soil in, what I'm going to end up having is good intimate bond between those two layers. So now that I've scarified that surface, I'm going to get the rest of my soil and I'm going to add another lift. So let's put some soil in there. And let's do our second lift. One, 2, 3, 22, 23, 24, 25. There's my second lift. Scarify again. Roughen up that surface. And now I'm ready for my third and final lift. It's real important to put enough soil in for this last lift so that when it's all compacted, the compacted soil extends above the top of the mold, so that when you take the collar off, and I'll show you, when you take the collar off, you'll have some excess compacted soil that you'll trim off using that beveled steel bar. So let's add some more soil. And let's compact our final lift. One, 2, 3, 22, 23, 24, and 25. Okay. What we've just done is we've compacted one specimen of soil using standard Proctor effort, at 1 target moisture content. Now, the modified proctor, as I mentioned, is the other test, and we won't do that demonstration because they're very similar to one another. The main difference, and really the only difference with respect to compacting, is that instead of having 3 layers, here you're going to have 5 layers with the modified proctor hammer. And you'll also have 25 blows per layer. So that's the main difference between standard and modified when it comes to actually compacting the soil. So what we need to do is we need to remove this collar, and hopefully when we do that, there'll be compacted soil above the top of the mold. So I have my steel bar with a beveled edge, and I'm going to very carefully trim that excess soil away. So that I have a smooth edge there. I trim that away. Okay, now I have my mold full of soil, flush at the top. I remove the mold from the base. And I'm going to take that mold full of soil and I'm going to place it in some kind of extruding device. Now there are all kinds of different devices out there for extruding soil out of these molds, and this is just one. So it's like a little car jack or something. So I'll raise that up. There we go. Usually the top of the mold has to line up with some groove. So I'll make sure that I'm lined up with the groove. Okay, looks like I'm seated, lined up with the groove in the bottom of this plate. So now I will extrude the soil. Here it comes. There it is. Okay. I need to obtain the net mass of the moist soil, the moist compacted soil. So I'll take that and place it on a precision scale. Make sure that the capacity of the scale is large enough to measure this large of a mass, usually on the order of about 3 or 4 pounds. And that net mass is M. Now that I have the net mass, I need to take this soil and I need to take some samples out of this soil to obtain moisture content. What I'll do is I'll take samples out of the top, the middle, and the bottom of the compacted specimen. I have 3 cans, so I'll obtain 3 moisture contents, and I'll calculate an average moisture content. So this is a pretty stiff specimen. What I'll need to do is probably take my screwdriver and gouge out a few pieces. From the top, from the bottom maybe, and maybe another piece from the middle. Just 3 different sections of the compacted specimen, making quite a mess here. And I'll obtain moisture contents. Now that I know the moist mass of the compacted specimen M, the volume of the compaction mold, V sub M, and the average moisture content, W average, I can calculate the dry unit weight of this specimen. So for a particular compaction effort, we repeat the test a minimum of 5 times over a range of moisture content so that we can establish a compaction curve, variations in dry unit weight with moisture content. We'll also perform this test at 2 compaction efforts, standard and modified Proctor. When you compact those 2 compaction curves next to one another, you see typically 2 concave downward curves where the modified compaction curve is shifted up and to the left relative to the standard curve. We can also plot something that's called the zero air voids curve. This represents dry unit weight versus moisture content for a saturated material. This curve typically is shifted to the right relative to the compaction curves, and it gives us a good idea as to whether or not our compaction curves are reasonable. We expect our compaction curves to be to the left of that zero air voids curve just a little bit. That's it for now. The next demonstration will be field measurement of moisture content and dry unit weight using the sand cone test. We'll see you then. Thanks.